Math 2415, Chapter 10, Vectors in the Geometry of Space, Section 2, Vectors, Video 7, some clarification. This was not originally in my list of videos to do, but as I was looking through the book between videos in preparation for recording them, I realized that I'm kind of using the notation a little bit wrong, and I want to clarify what I mean. So far, I've told you that R2 is the set of all ordered pairs, R3 is the set of all ordered triples, and Rn is the set of all ordered, for lack of a better phrase, n-tuples. Good luck auto-captioning that phrase, YouTube. But I've also been saying that, real quick, and you can represent these in set builder notation. R2 is the set of all ordered pairs, or equivalently, is the set of all things that look like this, such that X is an element of the real numbers and Y is an element of the real numbers. If you're not familiar with this symbol, which when drawn correctly looks like this, it's the symbol for the phrase is an element of, and states that an object belongs to a set of objects. In this case, X is a real number, so any number on the real number line. So R2 is literally the collection of all these ordered pairs. R3 is a collection of all these ordered triples where each coordinate comes from the real numbers. And in general, Rn is the set of all n-tuples where each coordinate is a real number. And I've been saying that R2 is the set of all vectors and R3 is the set of all vectors, and that's not entirely true. R2 consists of points in space, points on a plane. R3 are points in space, and Rn are points in dimensional space. But to say that this is a collection of vectors is incorrect, because an object in here is just a single point. It is not an arrow connecting one point to another. The correct notation for the set of all vectors is a capital V subscripted by the dimension. In this case, V2 is the set of all vectors with two dimensions, or two components, if you will. So in other words, it's the set of vectors such that the first component is a real number, the second component is a real number. And to get really abstract, the components don't even have to be real numbers. They can be complex numbers, or heaven help us, something weird like matrices or functions. But let's not push that envelope. So whenever you see something like R2, it is referring to individual points. When you see something like V2, it is referring to the vectors that you would get by connecting the origin to each of those individual points. Same thing over here. V3 would be the set of vectors, X, Y, and Z, or whatever you want to generically call the components, such that X, Y, and Z are all elements of the real numbers, getting a little bit lazy with the notation there. And the same thing down here for Vn, which is the set of all vectors, not ordered in tuples, but vectors, x1, x2, xn, such that x1, x2, xn is an element of the real numbers. So very subtle distinction, but from a theoretical perspective, it's worth pointing out that whenever you say R2, R3, or Rn, you're talking about individual points, whereas if you talk about V2, V3, and Vn, you're talking about all the vectors you can make. So very subtle distinction, and I'll try to make sure to maintain that distinction throughout the rest of this video series.